Welcome to BioIT World's Trends from the Trenches podcast, your insider's look at the science, technology, and executive trends driving the life sciences. I'm Allison Proffitt, editor of BioIT World. This episode is hosted by Stan Gloss, founder of BioTeam, a life sciences IT consulting company at the intersection of science, data, and technology. Joining Stan today is Mike Tarselli, Chief Scientific Officer at TetraScience. The two talk about everything from data's liquid metaphors, to productizing data outputs, to atomic habits, to advice for a data transformation. And they tell us what they really think about a data-driven discovery company. Let's listen in.
Hey, Mike. Thank you so much for joining me today. I'm really excited to talk to you about some of your views about data.
Thank you kindly, Stan. It's wonderful to be here. I very much appreciate the invitation. Thank you.
Yeah, so maybe let's just kick it off because not everybody knows you like I do. And maybe you could tell our audience a little bit about you and your background and the work that you do in the life sciences.
Sure, very kind of you. I've had a very interesting journeyman career sort of in the life sciences, maybe not where I intended to wind up. So rewinding all the way back, let's go back about 25 years. I thought I was going to be a doctor, like not a PhD doctor, but a doctor, right? An MD, the kind who helps people, treats babies, gets old people to feel better. And I told my whole family that for years. And just like probably every scientist's origin story, I entered college as pre-med and said, I'm going to do this whole thing. And then I got into AMT. I got into being an emergency medical technician, and I realized that things like blood and wounds made me hit the deck, which is no good when you're 6'1", 250. So that's not a good career path, maybe, if you're going to faint when you see your proximal case in front of you. So I said, what else can I do with my life where I'm still going to help people, but I'm not going to have to, diagnose them and, take their blood and stitch them up? And the answer turned out to be synthetic chemistry. So I sort of pivoted, went to chemistry, said, I'm going to, put everything into trying to treat people with drugs and therapeutics, and did, the classic thing you would do, which is got an internship at a biotech company, then got an internship at a pharma company, then, worked for a little while and saw everybody going to these secret meetings. And I said, what is that? Like, how do you get in the project meeting? And they said, you have to get a PhD for that. And I said, a what? So I went to go get a PhD and got that and called them back and said, I'd love to go into the secret project meetings now and talk to you about how you develop drugs. And they said, that's great. We'd really prefer to hire candidates with postdocs. And I said, okay, I'll go do a postdoc. So I applied, got a decent postdoc at Scripps Research and completed that in about 2 years, and then called them back and said, hey, I'd love to join you again. It's been 7-8 years since we last spoke. What do you think? And they said, sorry, it's the Great Recession. We can't hire anyone. So that necessitated a pivot into the data world. So I worked for a little while at a CRO, contract research firm. Then I worked at a startup, and I started on the side doing some science writing, some poking into databases and some shared formats about, how one exchanges information, some blogs, remember blogs, some different work with how you exchange data and information about science online without necessarily tying it to an experiment. And then definitely tying it to experiment with a role at Novartis where I was in information systems. And then the bug bit, I was like, wow, you can either stay in the lab at the bench for the next 40 years of career and maybe see, one receptor or one drug class through, and that'll be great. It'll be wonderful, and you'll probably help human medicine. Or you could look at the data and see everyone doing everything. And for a generalist like myself, who has wide interests and just loves to see how human medicine goes forward and what smart people think up, being on the data side is amazing because, one day is cell therapies, the next day is biologics, the next day is data structures, the last day is smiles and smarts in chemical reactions. And it's all open to you because you're on the side that's common to all of them, which is data production.
Right. So that's a really interesting background. And then data is really what we wanted to talk about today anyway. It's funny how just a story. I recently interviewed Mason Victors from Recursion Pharmaceutical, and I asked him, what's the difference between big pharma and the new pharma, like Recursion Pharmaceutical. And his answer was quite telling. He said, big pharmaceutical companies view data as the exhaust of their drug discovery process. We view data as fuel for our drug discovery. And I thought, wow, that's really telling about the different views of the world of the established, long established, some companies maybe 100 years old or more. And then the new digitally native companies that are coming out. Now, in your role, you get a chance to see both sides. So I'm curious, what do you think about that quote and how do you see it?
I still remember during my tenure at Novartis, I was with NIBR, which is the Institute for Biomedical Research, the sort of company inside of a company that leverages the research findings and doesn't necessarily have a tie-in to the commercial programs, so it can be fairly independent in its offerings. And Jay Bradner, who joined from Harvard and the Dana-Farber Cancer Institute, spent, I believe, 6-7 years there as president. And I remember very distinctly a town hall where he stood up and instead of saying, let's talk about our drug programs or let's talk about our modalities or our basic research, he said, guys, look, we produce data. Data is our outcome. We got to get around to that. We've got to understand that independent of standing up a new drug or a new platform or a new anything, we've got to get to the data and we've got to understand how to house it, what to do with it, et cetera. And it was very refreshing to hear a large pharma leader coming around to that. But honestly, Stan, that was 2018. So you're right. It's not a usual sentiment from a large pharma at this time. Smaller biotechs, I think, probably because they don't have process necessarily stood up in the beginning, and because they're told, move fast, here's some money, go as fast as you can, validate that target, get that first shot on goal, get something in the clinic in 2-3 years if you can. They need to move quickly and they need to rely on the data and smart interpretation of it to drive that. Whereas pharma has more of the horizontal infrastructure and heft. They've got process, lots of process. They've got stability. They've got, marketed products they can depend upon, which maybe means that, they can rely more on those physical, tangible assets and processes than the data.
Yeah. So a lot of the companies that I recently also interviewed Mike Montello, and Mike wrote an article related to the transformation from a project mindset to a product mindset. And I'm starting to see that actually starting to take shape in many of the established pharmaceutical companies like a GlaxoSmithKline. What do you think about that transition point between, projects which yield output and products which yield outcomes?
It is such an interesting insight, and it's so prescient because with this blending of the data world, so let's just even abstract that another layer back. Let's call it the tech world, right? The world of iPhones and Uber and trackable, calculatable health, quantifiable self, and then mixing that with the sort of traditional old world of pharma and some of the new biotechs as well. There needs to be that feeling of that tangible thing that produces a benefit in your life. You're right. If you do a high throughput screening campaign, or if you do the lead optimization as projects, you will certainly deliver something, whether that's don't go this direction, or a single lead, or, some ideas about how to optimize reactions or how to culture cells better. But you won't necessarily gain that thing you can point to that you can say, every time from now on, we're going to use the Stan ABC cell line, and it's going to do these things that we can measure and refine over time. That, I think, is a really good learning from the tech sector bleeding back into pharma, and that drives things better in that way. I love the product mindset. It's very valuable.
Yeah, and sometimes when I'm talking to people, they get stumbled about the word product because most people assume when we're talking about products, we're talking about something that somebody buys. So for me, my definition of what a product is if something is produced and consumed, that's a product. Anything that's consumable, that could be a product. Because many times in companies, we're not charging for data sets, but wouldn't the person who's doing a complicated AI and machine learning run benefit from us thinking of the data set that they're about to receive? We think about that as a product, and we have that pride in producing a high quality product.
I think you've got it on the nose. I mean, who consumes projects? Let's be honest here. Other teams, investors, and project managers. It's not really the thing that will be an outcome that's translatable to other groups. Whereas a product, you're right, a data set, or to use other analogies, you can use a product in a home setting, right? You could say a loaf of bread is a product. You're not going to charge your family to eat it, but you're sure glad you have one with specifications that can be reused, that has its own, good, high quality, tastes good, follows the same recipe, etc. But you wouldn't confuse the bread for the recipe, right? The project, let's develop the best kind of loaf.
Exactly. I mean, when you stop it, sometimes we see, because of the academic tradings that we have and people doing their dissertations and taking in their data for their dissertation. And in that kind of model, the data producer is the data consumer.
Mm-hmm.
So it's very, and when you start thinking consumer producer relationships, if the data consumer is the data producer, that kind of makes it feel like a silo, don't you think?
It most certainly does. I was actually just thinking as you said that I've seen a lot of journals adopt these shared data use policies recently, where they say, hey, here's some data sets, Mr. or Mrs. Reader, so you can see how we distilled the observations we did. And don't get me wrong, that's a wonderful step in the right direction. It's good to see gels and some sequence information and maybe some flow cyto or mass spec information, but it's still not productized, right? It's just, here's some raw data that I saved for you and put somewhere. It's not an encapsulation of what that data means and how you're going to wrap it up so that it's useful for the end consumer in a way it would be if you put it, say, for example, as a package on GitHub or as a open source Python library. Those are products.
Wow, that's an interesting concept. Imagine if we took and made publications, instead of being single attribution, first author, last author, most important, then everything in the middle. And think about breaking it down into a micro-publishing kind of way where everybody who does the work gets attribution. Maybe there's somebody who's a mathematician that does an amazing job analyzing the data. Maybe there's another person on the team who gets attribution by generating the data. I think part of what's causing us to hoard information is attribution, and maybe the attribution model needs to be relooked at.
I completely agree. Attribution and intended use. Intended use, I hate to say it, like beauty, is in the eye of the beholder. Just because you, the experimenter, had this intention out of what you wanted to find from the research doesn't mean that there's not multiple smart people downstream who can derive conclusions that will, befit what they need to do in their daily life. Such it is in the way of data and informatics handling. You constantly are told, well, hang on, we can't publish that to the preclinical database because my group hasn't had a chance to QC it, review it, upgrade it, whatever. Now, of course, there could be a regulatory or safety function. I'm not eschewing that. However, in many cases, it's just, well, I need to derive my conclusion from it before others can see it, or I'm worried they'll misinterpret it. Data are data. If you are a smart person empowered with tools downstream and you are in a different division or department or project, you should have every right to see what others are doing in the company.
It's so funny. As you were just saying this, there's a term that's thrown around all the time in the industry saying we're going to become a data-driven discovery company.
Yep.
Weren't you already data-driven? Haven't you always been deriving data in some way?
I hope so.
I do too. I mean, I think we need to start changing some of the vernacular in the marketplace and really talking about being data informed, because ultimately what we're really trying to get to is kind of like back in the 60s, I think Jay Licklider talked about man-machine symbiosis, And this whole idea of augmented intelligence, where the human and the machine work together as a partnership. And so trying to kind of create that environment where data is shared and valued and used, I think, is something we need to move more to. But some of these words that are in the marketplace just always make me chuckle a little bit.
I'd love to expand upon that with you a minute. Just the words we use to describe data. Yes, we want a data process, and yes, we want data to flow. However, it's always these liquid metaphors, right? Data lake, data pond, data swamp, data stream, data pipeline, data everything. And I get it because it gives people a nice visual metaphor to see things moving from place to place with an analogy everyone understands, which is potable water. But I often wonder if that also hurts us in the way in which we think about who uses it and who benefits from it.
Yeah, I mean, the Clay Christensen and all his work out of Harvard talked about the jobs to be done theory and figuring out that people, sometimes these tools that we talk about, the cloud, the data lake, like you said, those are just enabling technologies. It's really not. It's his example was people don't buy drills. They actually are looking to buy 1/4-inch holes.
Exactly. The ability the drill gives.
Yeah. So the idea is understanding what is it that our scientists are trying to do with their data, and then how do we deliver it to them in a just like in a product kind of format? Does it meet specification and all of that? And there are processes and there are ways in business that many businesses deliver high quality products to end users. And shouldn't we be doing the same with our scientists?
I would really hope so. And that's what I think all of us are aiming to do. Certainly you and your group are, and myself and ours, in that, you wouldn't be in this business. Let's be honest. If we have the backgrounds we all have, we could be doing a lot of things. We could be in finance, we could be in automotive, we could be in art, we could be in, influencing social discourse. But no, we've chosen biopharmaceuticals and technology because we think that there's something to be done here. And I agree with you wholly that we shouldn't be asking, hey, did you need to do that flow cytometry? Or hey, did you need to do that diffractometry? You should be saying, why did those cells need to be measured that way? Who needs to know that? And what conclusions will they draw? That's the real way to think about it.
Yeah, I love that. That's great. And again, when we move pivoting back to the product mindset, when we start thinking about how to improve data flows to people, there's a whole wealth of knowledge in supply chain thinking that really could be tapped into as we think about how do we move from raw materials through some kind of data refinery, which then ultimately lands as finished goods. I mean, let's talk about oil. Oil's pumped out of the ground. Even in its raw form, it has a value because they set per barrel prices on oil every day. It's shipped to a refinery, and then the refinery then has clients that want that raw material transformed into something that they can use. Some of it's jet fuel, some of it's gasoline, some of it plastic. All of these things. The one thing that's a little bit different on the data side is the ultimate destination for us is data sets that are reusable, because data is just one of those renewable resources. The more you use it, the more it gets valuable. So maybe you can talk a little bit about that, Mike.
I'd love to. First, supply chain analogies have probably never been more prescient because as we sit here recording this in the end of 2022, we are still, granted, we're probably in the denouement, at least I hope we are, of the COVID-19 pandemic. But, supply chain, I'm going to argue, probably wasn't something the bulk of humanity thought about too much prior to 2020. But then suddenly when they couldn't get basic goods and services like toilet paper and cereal and, yes, indeed, gas and fuel, they said, there sure is an impact from all of us on all of us and getting things. So I'm very glad that you made this analogy, and I'll continue it with you to say, yes, I believe in the data refinery. And I also believe a little bit like there's a very famous essay by Leonard Read called I, Pencil back in the 50s. And he talks about how, if you look at a full assembly process for any one good, he used the basic analogy of a pencil. There's no one person out there in the world who's making pencils by hand. It's assembled, right? By someone who cuts the wood and cuts it to length, by someone who gets the graphite out of the ground and puts it in tube format, by someone who assembles and anneals the pencil, and then someone who paints it, then someone else who boxes it, ships it, moves it, right? That same analogy holds for our data refinery, right? There are multiple consumers and producers, right? There's multiple producers, people who run core facilities, engineers, people who have point of service or point of care devices, systems like a LIMS or an ELN, for example. Then there's people who sort of harvest the data, take it in and move it around. There's people who upgrade the data. We'll call them data engineers, sometimes data analysts or scientists. And there's people who sort of pre-package and prepare the data, software engineers, and again, data scientists. And then, people who make sure that whole system is working, DevOps and infrastructure engineers. There's this large cavalcade of people that have to ferry the data from its raw format, unrefined format, through the refinery to the end consumer, scientists who need to know from it. And we should be both applauding them for their roles, because it's very, very important, but it's also something where we need to know a little bit about what each person's doing along that chain, and if that can be a person or if that's automation that takes its place.
Right. And today we're thinking about just the organization of data, but going downstream, it's going to be even more important when we go from the novelty of AI and machine learning, and now AI and machine learning is the way you do business every day. For some organizations who, like Tesla, it is.
Recursion too. Yeah.
And Recursion too. They're all built that way. So as we, so getting our data house in order now could not be any more important than today to get that house straightened up.
Again, to the Jay Bradner quote I've already done, and I'll do it again. If you see a pharma not as a medication or therapy producer, but instead as a data warehouse of kinds, talking about the 99 million ways not to make a drug or a therapy, and the one that really, really works, means that is just absolutely the number one asset of any biopharmaceutical concern, the knowledge that they are generating inside and what they're going to do with it and how they package it. So I agree with you. We not only have to prepare for MLAI, but we also have to prepare for a sort of, let's call it collaborative nexus that's going to happen, hopefully, in the next 5 to 10 years, where people start adopting these sort of industry best practices, standards, collaboration across pharmas, across organizations. You see some limited versions of that, but not in the same way as we have, for example, the internet or global photo sharing sites or global banks, for example. I'm hoping that more of that collaboration comes on. And how's that going to be driven? Well, by data, data exchange, data packets, data readiness. Right.
So you're in and out of many, many different companies, helping them with their data. Maybe what advice would you have for people who are going down a data transformation? I don't want to call it digital transformation, because there is no digital transformation without data transformation. So people who are on that journey, any advice from your perspective that you'd like to share with us?
Yeah, thanks for this. I'd say first, pause and look around. Every data or datum that you're going to generate is a reflection of a human or physical or mental process, right? So you should probably look around and say, is this the way I want my lab to run, my process to run, et cetera? And because the data, as we talk about, is a reflection of that. So first, get your process house in order. Get that new equipment, or get that new process, or automate that one thing first. Great. Now you've got at least your lab house in order. Then look at your data, and say, okay, I have how many different kinds of data coming in, to where, who needs them? What model should I distill from that? Do I want to follow something like Conway's Law, humorously derived in the 70s, that says that an organization's data and information is organized by its org chart? Probably not.
Yeah.
You probably want something slightly more centralized and standardized, and you probably want something where you're thinking up front about universal UIDs and some standard ontologies and some standard terminology, some definitions and glossaries, standard APIs to do little microservices that say, okay, I'm just the publishing endpoint, I'm just the retrieve endpoint, I'm just the index endpoint, right? Doing these very, very basic things. I know it sounds a little bit pedestrian, but if everybody did these little sort of 1% and 5% hacks here and there, you would have a 20x better laboratory in 2 years.
Wow, that's so funny because it reminds me of the book that I read, Atomic Habits.
Certainly.
There they talked about the crazy thing about making a 1% improvement every day. And that compounded over a year gets you about a 30 or 40% improvement each year by just focusing on 1%. So the idea of you don't have to go big to have impact. It really is focusing on putting the efforts on the things that really matter, that really get you moving. So
yeah. My apologies. Though I wouldn't claim to be a executive who rides astride of a large multinational pharma, I would say that digital transformation initiatives or data transformation initiatives tend to fail when they go too big, right? When you try to change the whole way the whole business or the whole industry does things, you're almost doomed to fail because the scope is too large and people can't get around that. But these small changes that you're saying, these atomic habits, you can go that way.
Right. So we spent a little time talking, and one of the things is you work for a company called TetraScience. And can you tell us a little bit about your company and what it does? Because I'm sure people would be interested to hear a little of that story.
Sure, I'd love to. TetraScience is we're a startup. We actually have quite a few people now, so I don't know, we're getting a little long in the tooth to be a startup, but that's what we are. We are a scientific data cloud. So what does that mean? Let's pull that apart. First, scientific, we only serve the biopharmaceutical industry and its scientists, data scientists, and informatics professionals at this time. Data, right? As you just said, data transformation. We are a data transformation company. We take data in from source machines, instrument systems. We move it through a kind of version of the data refinery you and I are talking about, and we push it downstream to consumers like ELNs, LIMS, visualization, machine learning algorithms. And then finally, cloud. Well, we are cloud native and cloud only. We don't have an on-prem or installed version of our platform. We are entirely in the cloud, and we hope that everybody else sort of follows that trend that finance and government and retail have done in the past, which is moving to the cloud now that we've sort of established that you can safely run computational and imaging and genomics workflows up here. We think you can run basic science workflows up here as well. So if you work with us, what we do is we come in, like we talked about, we kind of do data transformation with you. We look at what your source systems are. We say we would, imagine doing it this way. We recommend some changes. We document some use cases. We establish how that would run on the platform and how we do it with integrations to multiple different vendors and different data types. And then we watch as that gets moved to the cloud, transformed and harmonized into an easily consumable format, and then published where you need it to go. So our hope is not to be, if you walk into a dark room, and you turn on the lights. We're not the light switch. We're not the point of interaction like an ELN or a LIMS or an MES. We're also not the light bulb. We're not the insight you're going to generate. We're everything in between. We're all the wiring, the drywall, the fuses, the everything that makes that work.
That's terrific.
Thank you.
Well, that's terrific, Mike. Listen, thank you so much for joining me today on this journey through our discussion about data and data transformation. And I really appreciate your time and really have enjoyed so much talking to you, Mike.
Hey, Stan, I appreciate your preparation, your fortitude, and for hosting this and thinking about it in this future-leaning way. Much appreciated.
Take care. Bye-bye.
Take care.
Thank you for listening to BioIT World's Trends from the Trenches podcast.